CPT 209, Chapter 15, Connecting to and Setting Up a Network. Here are the objectives. They can be found in your textbook as well. Understanding TCP, IP, and Windows networking. So the client-server applications, the client being the workstation for the user, and then the server, the main computer, the server normally in a separate room. So typically there are two computers and two applications involved, and communication occurs on three levels: hardware, operating system, and application, and it's dependent on one computer addressing the other computer. When two devices communicate, they have to use the same protocol. Basically, the protocol is the language. Almost all networks today use a group or suite of protocols that are referred to as TCP/IP. The TCP is one, transmission control protocol, and then Internet protocol is another protocol. Data is broken into segments, and then the segments are put into a packet. So the packet will contain the data and the information, and that's going to identify the type of data, where it came from, and where it's headed. Level 1 for your layers of network communication. Hardware level. So the root level of communication is basically used wireless or network cables, phone lines, TV cable lines. That includes the network adapter and MAC address. MAC stands for Media Access Control, and that's a unique 48-bit hexadecimal number hard-coded on the card by the manufacturer. And then it's also referred to as hardware address, physical address, adapter address, or Ethernet address. And also on that level 1, the communication protocol is used. So here is a diagram that is showing the network communication in the layers. Level 2, operating system level. So that manages the communication between itself and another computer, and they're both speaking the language TCP/IP. And that uses IP addressing. So here's a diagram depicting that. Okay, layer 2, operating system level continued. It has an IP address. Your IP address is going to be a 32-bit or 128-bit number that's assigned to a network connection, and that IP address is used to find computers on a network, a subnetwork, and even the internet. Okay, level 3, the application layer. That is where the client communicates with other server applications, and it's using a port number, and the port number is used to uniquely identify a computer application. And then the socket is the IP address followed by a colon and a port number. So in our example of an email, it's 36.60.30.5:25, and then for the web server example, it's 136.60.30.5.80. So here it's showing a diagram of the server running on a computer. Each server is addressed by a unique port. Okay, how IP addresses get assigned. A MAC address is embedded on a network adapter at the factory. IP addresses are assigned manually or by software. A static IP address is a manual, permanently assigned address that is assigned to a computer or device, whereas a dynamic IP address is assigned by a server each time the device connects to the network. So the IP address that the device has now will not necessarily be the same IP address the device has next time it connects. A DHCP, Dynamic Host Configuration Protocol server, assigns addresses to a DHCP client that is requesting an address. So as the device connects, it is basically asking for an IP address, and that IP address comes from the DHCP server, and then the device that's trying to connect to the system, the network, is considered the DHCP client. An IP address has either 32 or 128 bits. The IP version 4, Internet Protocol version 4, uses a 32-bit address to identify a network connection, and currently the IP version 4 isn't doing so well because we're running out of addresses. So in walks IP version 6, Internet Protocol version 6, and that's created partly due to the shortage of the IP version 4 addresses, and that uses 128-bit IP addresses. The Internet Assigned Numbers Authority is responsible for keeping track of the assigned IP addresses. IP addresses are 32 bits long, made up of 4 groups, and each is 8 bits long. So this is for your IP version 4 IP addresses. So there's 4 decimal numbers separated by periods. So here you see 72.56.105.12, and that translates into the largest possible 8-bit number. So you see that there are 8 ones, which is the same as 255 in decimal. So the largest possible decimal IP address is 255.255.255.255. In binary, that is read as 18 times .18 times .18 times .18 times. An octet is each of the 4 decimal numbers, 0 to 255, and then that gives us 4.3 billion potential IP addresses. But remember what I just said, we're running out of IP version 4 addresses. How IP version 4 IP addresses are used. So the IP address identifies a network and host, and then the classes are based on the number of possible IP addresses in each network within each class. For example, class A, the IP addresses would begin with the 1, go through 126. B, it would range from 128 to numbers that start with 191, and then C would begin with 192 and range to numbers that start with 223. So the class A address, the first octet identifies the network, and the last 3 can be used to identify the host. For a class B address, the first 2 octets identify the network, and the last 2 can be used to identify the host. Whereas a class C, the first 3 octets identify the network, and the last octet can be used to identify the host. Here they are showing us class D addresses, and that includes octets 224 through 239, and that is for multicasting. And then research uses class E addresses, and those octets are 240 through 254. A few IP addresses are reserved for certain uses. So 255.255.255.255 is used to broadcast messages by the TCP IP background processes. 0.0.0.0 is currently an unassigned IP address. And then 127.0.0.1 is considered a loopback address, which means it is referring to your own computer. Subnets using IP version 4, large networks can and should be divided into smaller networks, and those are referred to as subnetworks. Oftentimes, you just hear it referred to as subnets. To divide a network into subnets, you designate part of the host portion of the IP address as a subnet. So here's an example of a Class A network of 69.0.0.0. On network 69, you could have 16 million hosts. You can divide this network into 256 subnets by using the second octet for the subnet address. So the possible network numbers would range from 69.0.x.y, those are just unknown numbers, to 69.255.x.y. So the second number, the lowest, could be a 0. The highest could be a 255. Okay, so the subnet mask identifies the part of the IP address that is the network ID and which is the host ID. Subnet masks help a device know if an IP address is part of the network or if it belongs to somebody else's network. Subnet masks, that's a group of 1s followed by a group of 0s. The classful subnet masks all 1s, all 0s in an octet. Classless subnet masks are a mixture of 0s and 1s. A network is divided into a subnet when the subnet mask takes some of the host portion for the network ID. So here's an example, dividing 69.0.0.0 into 256 subnets. So the subnet mask would be 255.255.0.0 instead of the 255.0.0.0. So an address of 69.12.34.56 with the subnet mask of 255.255.0.0 would result in a network ID of 69.12.0 and then a host ID of 34.56. A public IP address is an IP address that is available to the internet. A private IP address is used on a private network. For example, our printers here on campus, even though they're network printers and they have an IP address, they have private IP addresses. So the printer in our lab, the IP address starts with the 10. If you're in the lab and you're part of that little world, you can see that printer based on the IP address. If you are in an outside world and you try to print to that printer and you type in that IP address, you're not going to see it because you're part of the public, and that printer is part of a private network using a private IP address. Private IP addresses use router with a NAT, network address translation redirection for internet access. IEEE recommends that the following are used for private IP addresses: the 10.0.0.0 through 10.255.255.255, and then there's another range that starts with 172 and another range that starts with 192. IP version 6 IP addresses. So IP version 6 has 128 bits and it's written as 8 blocks of hexadecimal numbers, and they are separated by colons. So here's an example. 2001 colon 0000 colon 0B80 colon 0000 colon 0000 colon 00D3 colon 9C5A colon 00CC. Each block is 16 bits. The leading zeros in a 4-character hex block can be eliminated. So if you look towards the end of the original address where it had a colon 00D3, they are now showing it, which is colon D3. If a block contains all zeros, they can be written as double colons. So if you notice, it's B80 colon colon. Only one set of double colons is used. Okay, so terms used in the IP version 6 standard. Link, which refers to a local link. That's a local area network or a wide area network bound by routers. Interface, those are nodes attachment to a link. They can be logical or physical. Logical attachment is used for tunneling, which is used by IP version 6 to transport IP version 6 packets over an IP version 4 network. Interface ID is the last 64 bits or 4 blocks of an IP address, and then neighbors are 2 or more nodes that are on the same link. 3 tunneling protocols for IP version 6 packets are used to travel over an IP version 4 network. The intra-site automatic tunnel addressing protocol, Teredo, and 6TO4. 3 types of IP version 6 addresses: the unicast address, so packets are delivered to a single node on a network; multicast address, where packets are delivered to all nodes on a network; and then the anycast address, that's used by routers, identifies multiple destinations and packets, and they are delivered to the closest destination. So there are 3 types of unicast addresses: the global unicast, or global address, that can be routed on the internet. Most of those begin with the prefix 2000 colon colon WAC3. The WAC3 indicates the first 3 bits are fixed and always 001. Link local unicast, link local or local address, that can be used for communicating with nodes in the same link. Most begin with FE80 colon colon WAC64. And then unique local address, ULA, identifies a specific site within a large organization. The prefixes are FC00 colon colon WAC7, FD00 colon colon WAC8. Here are 3 types of IP version 6 unicast addresses. Viewing your IP address settings. So you're going to use the ipconfig command in a command prompt window to show the IP version 4 and IP version 6 addresses that are assigned to all the network connections. The IP version 6 addresses are followed by a % and a number. The number is called the zone ID or scope ID, and it's used to identify the interface in a list of interfaces of a computer. Here is a picture or a screenshot, and it's showing the different IP addresses, where they're assigned, and that type thing. Character-based names identify computers and networks. So the character-based names are a substitute for IP addresses. So the host name or computer name is going to be the name of a computer. So because we're in Lab 131, we might have a computer name Lab 131-1, and that would let us know that's the first computer in Lab 31. And then maybe we have another computer in there called Lab 131-8, and that would let us know it's the 8th computer in Lab 131. The workgroup name identifies a workgroup. The domain name identifies the network. And an FQDN, a fully qualified domain name, that identifies computer and the network in which it belongs, and it uses name resolution. The DNS server finds the IP address when the FQDN is known, and then the Windows uses a host file. Here is a diagram that shows how software protocols and technology on a TCP/IP network relate to each other. TCP, Transmission Control Protocol. It's connection-oriented. It checks whether or not the data is received, and if it's not received, it will resend the data. When a TCP packet reaches the destination, an acknowledgement is sent back to the source. If the source does not receive the acknowledgement, then it'll resend the data, and that's used by web browsers and email. UDP, User Datagram Protocol, that's a connection list protocol, which means it's the best effort. It tries. If it makes it, it makes it. If it doesn't, it doesn't. HTTP, Hypertext Transfer Protocol, HTTPS, is secure, so it encrypts and decrypts data before it's sent and processed. SMTP, Simple Mail Transfer Protocol, that's used to send email. SMTP Auth is SMTP authentication. POP and IMAP are ways to deliver email messages. And then Telnet is the way to remotely control a computer. LDAP, Lightweight Directory Access Protocol. That's used by clients when an application needs to query a database. SMB, Server Message Block. That's used by Windows to share files and printers. FTP, File Transfer Protocol. The transfer of files between two computers uses FTP. And then it can use browsers, Windows Explorer, or even a third-party software program to transfer files. SSH, Secure Shell, that's used to pass login information to a remote computer and control that computer over a network. SFTP, Secure FTP, that uses encryption to transfer files. SNMP, Simple Network Management Protocol, that is used to monitor network traffic. RDP, Remote Desktop Protocol, that's used by Windows Remote Desktop and Remote Assistance utilities to connect to and control a remote computer. Connecting a computer to a network. So when you connect a computer to a network, most of the time it's quick and easy. You have different ways of connecting to a network. Ethernet, wireless, and dial-up connections are all very typical ways of connecting to a network. If you're connecting to a wired network, you have to have a network adapter installed, and then you're going to have network cable connected to your RJ45 port and your network port. You typically will verify that this connection is made by verifying the lights. Windows is going to assume that it's using dynamic IP addressing, and then you're going to verify your internet connectivity. If that doesn't work, you need to troubleshoot. So you want to verify that the device manager sees the adapter and it does not report errors. It'll report errors by using either a question mark or an exclamation point. If an adapter does not have an error but you're still not able to connect, you want to open the Network and Sharing Center. A red X indicates a problem, so you're going to click on the X to start up the Windows Network Diagnostics. Hopefully that'll take care of it. Windows will resolve the problem, and then you should be able to connect to the internet. Here's a diagram of the Network and Sharing Center. Okay. Follow these steps to verify and change the TCP/IP settings. So in the Networks and Sharing Center, you want to change your adapter settings, go to Properties, To change to static, you're going to enter the IP address, subnet mask, and then the default gateway. If you have the IP addresses of a DNS server, you want to check next to use the following DNS server addresses, and then you're going to enter the IP address or addresses. You can have up to 2. If you're using a laptop that's going to go from one network to another, and one of the network uses a static IP address, you want to choose the alternate configuration and then select user configure in order to enter the static IP address information. If the general tab is configured for dynamic, the computer will first try to use that, but will apply the static if the dynamic is not an option. Okay, so here's a diagram of resetting a network connection. Wireless. So your wireless could be an unsecured public hotspot, McDonald's, whatever, or it could be a secured private hotspot. Network at your house, maybe. So here are the steps to connecting to a wireless network in Windows 7. You need to have a wireless adapter. You need to make sure the wireless adapter is turned on. If the network that you're trying to access calls for a password, make sure you enter it. If the network is unsecured, McDonald's, you want to verify that Windows has configured the network as public. That'll help protect you a little bit more, but don't have that false sense of security. You're not totally protected. Okay, so it's asking you to test the connection. Some hotspots have a home page and you have to enter a code or a little check mark next to I agree or that kind of thing. So methods used by access points to secure wireless networks: a security key. SSID is not broadcasted. SSID is the service set identifier, basically the name. Only computers that have registered MAC addresses are allowed to connect. So you want to find out the MAC address of a computer by using the ipconfig whack all command. Okay, what's needed to connect to a wireless wide area network, WWAN? Hardware and software. A SIM card, subscriber identification module. That's a flash memory card that contains the information you need to connect to a cellular network. Password and authentication information, encryption standards, and services that your subscription includes. Here they're showing you the back of a cell phone, a little bit of an old cell phone, and they're pointing to the SIM card that is installed in the slot. So to connect to a wireless WAN cellular network, the options for hardware and software, you're going to use an embedded mobile broadband modem, tether your cell phone to your computer, and then use a USB broadband modem. Connecting to a cellular network, you're going to use an embedded broadband modem. Insert the SIM card provided by the mobile operator. Also need to use software either provided by your operating system or your mobile operator. If you're using your cell phone, install the software provided by the mobile operator and tether your phone to your computer. If you're using a USB broadband modem, make sure the SIM card is inserted in the device, then insert the modem into a USB port. Windows will find the device and software installed on the device if it's set to automatically run. Creating a dial-up connection, old school, still in existence though. So you're going to have a dial-up modem, either internal or external. The modem is going to use a telephone line. There needs to be a connection between the telephone line, the PC, or the modem, and then the modem is going to be part of your PC. Open your network and sharing center window. You're going to choose set up a connection or network, and then you're going to select set up a dial-up connection and then choose next. And then you're going to enter the information that is necessary for your ISP, internet service provider. Here they're telling you how to use the connection. So if you are using a dial-up connection and you're having problems, things that you wanted to verify in your troubleshooting process is to make sure the phone line and the modem are both working. Check the dial-up connection property box to see if any errors have been reported. Try manually dialing the number from a telephone. Try another phone number. listen for the number that's actually being dialed, and then remove and reinstall the dial-up connection. Sometimes it gets in there just enough to think it's there, but not all the way to make it work properly. So it's just a matter of removing it and starting over, getting it all out of its system. A VPN, virtual private network, is used by remote employees to connect to a corporate network by way of the internet. So the data is encrypted using a technique called a tunnel or tunneling. The VPN is often managed by client-server software. Windows can be used to create a VPN connection instead of third-party software, and then a VPN connection is a virtual connection, so you can't really see anything, but it's really there. So the general steps for connecting a VPN, if you're using Windows 7, you're going to go to your Network and Sharing Center. You want to connect to where it says in the Connect to a Workplace box. You want to use your internet connection, and you're going to follow the prompts. And all this information is in your textbook as well. Setting up a multifunction router for a SOHO network. SOHO is small office or home office. So in order to set up a SOHO, you need to know how to configure a multipurpose router and how to set up and secure a wireless access point. The functions of a SOHO router: it stands between the ISP network and the local network, and it routes traffic in between. If another function is as a switch, it manages several network ports that can be connected to wired computers or other network devices. The third function is as a DHCP server. All computers receive their IP address from the server. Function 4 is as a wireless access point. A wireless computer can connect to the internet via the SOHO router. Fifth function is a firewall, so it will block the unwanted traffic from the internet, and it provides the network address translation NAT so that computers can use private or local link IP addresses. Also can be used to restrict internet access for computers. The sixth function is FTP server, so it can connect an external hard drive and FTP firmware on a router, and that can be used to share files with network users. They're telling you how to install and configure a router on the network. You want to make sure you are following the directions that are given to you by the manufacturer. Some routers may have specific things that need to be done before one step can be done, that kind of thing. So you want to make sure you are following the directions of the manufacturer, and then you want to test the connection by using the browser to access the internet. Okay, installing and configuring the router on the network. So you're going to use a browser and firmware on the router to configure the router. Configuration changes to possibly make to the router's configuration. Change the router password. Change the SSID and configure the DHCP server. View the assignments by the ISP. Assign static IP addresses, configure the firewall. You want to disable all the ports. And then, so what you want to do is you want to keep in mind things like, if I'm living in a neighborhood in South Carolina and everybody has Carolina stuff in their yard, but yet I have Longhorn stuff, and then I name my network Longhorn, it's going to be easy to tell the network is probably mine. We don't want that. I don't want it to be easy to identify my network, because if somebody knows something about me and they know it's my network, they would have an easier time of trying to infiltrate my network than somebody else's. Also, you don't want to use the ID that is based on the type of router that you have. Because, let's say, it's a Cisco 1234, and the name of my network is Cisco 1234, and I don't change the password, what can happen is somebody can do a little snooping. They know what kind of router I have because I left it as whatever the original name was. Then they can go and do a little research to determine the default password for my router, and they're in my system very easily. Port filtering. Port filtering is used to open or close certain ports. Applications are assigned the port so that You can filter control what applications can or cannot do when a firewall is involved. Port forwarding is when a firewall receives a request for communication from the internet to a specific computer and port, and the request will be allowed and forwarded onto that computer. Port triggering opens a port when a computer on the network initiates communication through another port. DMZ is the demilitarized zone. That's a computer or network that's not protected by a firewall. Bad, bad, bad. So tips when using port forwarding or port triggering: must lease a static IP address from your ISP. For port forwarding to work, the computer on your network has to have a static IP address. If the computer using port triggering stops sending data, the router might close the triggered port before communication is complete. If using port forwarding, your computer and network are more vulnerable, because you're allowing external users to directly access your private network. Setting up a wireless network, Wi-Fi, wireless fidelity standards have evolved over the years. So the IEEE 802.11 standards are what we use when we're referring to Wi-Fi in general. But if you'll notice, there are different flavors of that. So for example, IEEE 802.11a, obsolete, that kind of thing. IEEE 802.11n, indoor range up to 70 meters, outdoor range 250 meters, can use 5 gigahertz or 2.4 gigahertz radio frequency. So N is the latest Wi-Fi standard. It uses MIMO, multiple input, multiple output, and that means a device can use 2 or more antennas to improve performance. Most wireless devices today are 802.11b/n/g 802.11b WAC-G WAC-N compatible. Place your router or wireless access point in the center of where you want your hotspot. A higher position works better than a lower position, and you want to make sure that it is physically secure. 802.11n configuration options to consider: either 5 gigahertz or 2.4 gigahertz for radio frequency. Older wireless devices that will use the network, for example, the B or G flavors, those are going to need the 2.4 gigahertz. Radio frequency interference, that can cause problems. The channel the network will use, the channel width for the network is going to be 40 or 20 megahertz, and then the radio power level the device will use. Those are all things to keep in mind. Securing a wireless network: require a security key and use data encryption. There are 3 types of protocols for encryption. WEP, not a good idea. WPA, really not that good of an idea, because WPA2 is out, and that's the best encryption standard we have right now. You want to disable your SSID broadcasting, so I need to know that that's there versus it just saying, hey, here I am, if you want me, grab me. Filter the MAC addresses. It's a security measure, but it's not a strong one because it's not using encryption. But what you can do is say, only the following MAC addresses can access my system. Or if there's something that you know is bad, you can block it. Wi-Fi protected setup, WPS, that generates the SSID and key using a random string of hard-to-guess letters and numbers. Here's the summary of the chapter. The summary continue. And that concludes this chapter for CPT 209.